Hello everyone. If you work with simple moving averages for your stock watch list and need a better way to manage them, today I'll show you a custom function in app script that can help you streamline your analysis. As you know, SMA is an important toolkit for a technical analyst. Calculation is done by conducting arithmetic average on a subset of the data. This subset is called a period. Here I am showing a 2 and 3 period simple moving average. You see the 2 period is calculated by averaging the prior 2 data points and moving down the range. Similarly, 3 period is calculated by averaging prior 3 periods and moving down the range. Also note here you cannot calculate SMA for the first period on a 2 period moving average as there is no data. This will hold true for other periods as well. Basically, you will not be able to calculate SMA for n-1 data points. There are many uses for SMA, but one is to signal buy and sell of a stock. Here I overlaid the daily candlestick chart of Google with 50-day and 100-day simple moving average. The shorter period SMA is called the faster moving average, and the longer period moving average is called the slower moving average. Thus 50-day is the faster moving average here. When a faster moving average crosses above a slower moving average, that signals a buy, and when it crosses below the slower moving average, that is a signal to sell. This is just one of the uses of SMA. Okay, without further delay, the way we tackle this problem is by first creating an average function in app script. We unfortunately have to do this because Google Sheets or app scripts does not allow the use of built-in function to operate within app script. We'll use this average function to create a bare bones simple moving average function that we'll use to create the final function I showed earlier. I find dividing them to be much simpler to code and understand later. Okay, the first thing that I have already done is open app script from tools menu and filled in the JS doc documentation for our custom average function. This function will use JavaScript's reduce method. The reduce method executes a reducer function on each element of the array and returns a single value. We are using arrow function, and reducer function has two parameters. Results, which holds the result of the sum on each element, and value, which is the current value in the array. So we'll use reduce function to find the sum of the array and use length method on the array to find the number of elements in the array. So our sum divided by the number of elements will give us the average of the array. This will work only for a vertical range in the Google Sheet. We can use a transpose function to make it work on horizontal range as well, but the data on closing price are mostly in vertical format, so I will not go in that direction for now. In the reduce function, I have used parse float on the current value in the odd chance that the numbers are read as string. The 0 is initial value for result. So first iteration of our function will return 0 plus the first value in the array, and subsequently the return from previous iteration will be the value of result, leading ultimately to the sum of the array. If we test the myAverage custom function, we see the autocompletes work and the function works as well. Comparing it with the built-in function, the results are the same, but you see the difference in execution speed of the built-in function. It's always better to use built-in function. Before we go forward, we have to understand how app script holds the data. It holds the data as arrays of array, like shown here. Our arrays until now were single dimensional, so we did not have to think about the transformation of the array from one shape to another. However, once we include multi-dimensional array, we need to create a function that will transpose the array from one shape to another. I intended to create a nested for loop to transpose the array, but found this cool transpose function which also gives the logic of the transpose as well in the author's website. You can find the link in the description below. The transpose function will take in an array A. It gets its object dot keys for the first row, that is A0, which is the row with the serial number, name and city. This object key array will have 0, 1 and 2 as its elements. The outer map function will iterate over each element of the object key array. In the first iteration, the argument will be c equals to 0. Then the inner map function will iterate over each element of the array A. That is, in the first iteration it will go over the serial number, name, city row, and the last iteration it will be 3 Tom LA row. Now the return RC will on the first iteration take the first row, that is serial numbers, name and city, and return its 0th element. For each iteration of the inner map, the column remains fixed at 0, and after the rows are done with, the outer map will substitute C with 1, and the process follows until the array is transformed. Our next function will return a single column simple moving average given a single column range, a period, and it will also be able to return a result if there is a single cell header in the range. So as the documentation reflects, our parameters for the function are range period as integer and a boolean for header. We'll name this function as SMA1. The first thing we need to do now is check if the provided range has header, and if it does, then we have to remove the first row of the array to remove the header, so that our myAverage function can work on the array. We will do this by using JavaScript's conditional operator, the syntax for which is shown in the screenshot here. Basically, we check if a condition is true and return an array, else if the condition is false, we return a separate array. Next, we'll run some if statements to check whether user provided arguments are viable or not. The first thing we do is check if the user supplied period is less than 1, that is 1, 0 or any negative number. If it's so, then we cannot have a simple moving average. Similarly, if period is longer than the array itself, then we'll also need to throw an error. Now we can use map method of array. Map method returns a new array based on the return of a function applied to each element of the array. Our function in the map method will have index number and the current value. We'll use these two parameters to slice the values of our array, so our myAverage function can work on the sliced array, leading to a new array that will contain moving average for each value within the array. The function within map is iterating through each element in the array, and for each element it checks whether the element's index number is less than user supplied period minus 1. If so, it will return a null value. This is because user supplies period number based on an index starting from 1, whereas app script starts its index from 0. If the index is greater than or equal to period minus 1, then inside the else block, the values array is sliced from index minus period minus 1 to index plus 1. Index plus 1 again is to balance the 1 based index of spreadsheet with 0 based index of app script. Finally, the function returns an array of null and averages, which is assigned to SMA1. We now use conditional operator to check if the user supplied a header in the range, and if so, rejoin the header in the simple moving average output as header space SMA dash period format using concat method of array. Else, we just return the simple moving average. Let's check our new function. We'll use googlefinance function to get some data on Google. Our content assist works. So does our function, except for the header, which should have been values 1, as that is the original range with header in line 39. Everything should work now. Let me check couple of other values. And all of them works. Next, we'll create the final mySMA function using this function. Now we will create our final function, for which I have already typed out the documentation. Basically, this function will take in a range with date and asset prices, multiple comma separated periods supplied as string, boolean to whether return the original range as well, and a boolean for header. Given these parameters, it will provide multiple n period moving average. I will name this function mySMA and the parameters as values, period defaulted to 5 and 10 period, and true for both returning original data and having a header. The first thing to do is check the supplied range for number of columns. We will limit it to 2 columns, with the first column being date and second column being values. If the first row of the provided range is greater than 2, it will throw an error. Next, we need to pass the period that is supplied as comma-separated string to an array of number. For this, we will use split method and map the returning array to number by using number method. What this does is it converts the string to number. Next, we assign a variable values calls with the number of columns in the supplied range. We need this to slice the data to have only the prices data for my SMA function to work. We then create an empty array called SMA to hold the simple moving averages. Now we use the if statement to check if the range provided is single column, and if so, we'll run my SMA1 function on the range for each of the period in the period array. We include a return statement with a conditional operator to see if the user wants the original data as well. If they don't want the original range, we return the transposed SMA generated in the if block. Else, we append the SMA array to the original range using map function. Basically, we iterate each row in the original range and concat the corresponding column from the SMA array. Now our else block starts, which is activated if there are more than one column in the supplied range. The first column is expected to be date column, so create a variable values1. We run a map method on the values range supplied by the user, which goes through the range, and for each row will return the second element of the row, that is the price data. We do not need the index in the function in this map method, but since I put it there already, it does not create any problem. I left it there. This creates a single column range, and the rest of the code is identical to the if block above. It's all done, and we will check our function. The content assist works as expected. Let's try with both date and prices and return a 5-day and 10-day simple moving average. I will set both original and header as true here, and it works. This function will take any workable array, and since Google Finance formula returns an array, we can directly supply Google Finance formula here. If we want to insert chart, then we can do it as well. One benefit is I can change the data directly in the formula itself by changing the arguments for the Google Finance using this method. Unfortunately, because of restrictions in apps script, we cannot insert a chart using formula. Otherwise, it would have been a perfect function. Few tweaks here and there, and the chart I generated now is the same as the chart I showed you earlier. Please do let me know what you think of this function. Thank you for watching this. Have a nice day.